Thank you for joining this lesson. We're going to handle physics paper 2. Number 7, we're being told that below is a radioactive decay. So the radioactive decay equation is having an element A, which is having a mass number of 232 and an atomic number of 90, releasing K particles to become a daughter nuclide B, having a mass number of 228 and an atomic number of 88. Then they further release, or the reaction continues, whereby gamma radiations are released to obtain C, which is having an atomic number of X and a mass number of Y. Then identify radiation K. There is a radiation being emitted such that mass number reduces by 4, because from 232 to 228 we have a difference of 4. So if we assume that K is having a mass number of 4 and an atomic number of, we can see 2 is lost. So the element which has a mass number of 4 and an atomic number of 2 is helium. And when helium particles are released, then such type of a radiation or radioactivity is a alpha radiation. So K is alpha radiation. Alpha radiation. So further research on alpha radiation reveals that alpha particles are just elements of helium. That is why after the calculation we can see helium is the only atom which will have such a structure. Determine the values of X and Y. X and Y as the atomic and mass numbers of C respectively. When gamma rays are released, it is just a form of energy and it is lost such that the mass and atomic numbers of the element are not affected. Therefore, C, though it has become a new nuclide, it will have the same atomic number and mass number which B add. So X is going to be 228, Y is going to be 88. Y is going to be 88. Then another question here. The figure below shows a ray of light passing into a glass prism ABC. The glass prism is equilateral. We can see 60 degrees all over. 60, 60, 60. Then we are told this is the normal. This is the normal. So the normal should be labeled here, not here. Then we are now told to sketch the path of the ray as it travels from face AC. So the next behavior of the ray, given that critical angle of glass is 42 degrees. Now, if this is 60, and we know that when a ray of light meets an interface at right angle, there is no refraction. So it is passing at 90. So this is 90 and this is 60. We will have this one as 30 because this is a triangle. So it will be 30. Now this one is 30. The angle here is going to be 60. It should be known that the angle of incidence now for this other interface is 60 degrees. Now the angle of incidence being 60, it means the angle of incidence is now greater than critical angle, and for that particular medium, total internal reflection is going to occur. So this ray, instead of being refracted to the air, we will have total internal reflection occurring, such that because total internal reflection occurs obeying the laws of reflection, we will have the angle of incidence being equal to the angle of reflection. So the ray will behave like that. This means it has left 30 degrees here, and with 30 degrees at that point, and this is already 60, it means the face BC will be met at 90 degrees, and at a right angle, a ray of light passes undeviated. There is no refraction again. So the ray now will proceed to the air. So that is how the ray behaves beyond AC. Again, we got a question, number 9, which says that an electric heater is rated 100 watts, 1000 watts to 40 volts. Calculate the resistance. This is resistance of this element. Calculate the resistance of the element. So what we're going to have is that with power and the voltage, we're going to say that power is given by voltage times current. Therefore, to remain with current, we need power divided by voltage. So 1000 out of 240. This will simplify to, use a calculator, 1000 out of 240. This gives us 4.1666 recurring, so 17 amperes. But again, we know that from Ohm's law, V equals to IR. This is Ohm's law. So for us to get resistance R, we need voltage out of current. Voltage divided by current. Therefore, a voltage of 240 out of a current of 4.167, this will give us, when we divide 240 and this answer, exactly 57.6. 57.6. Because this is resistance, the units will be ohms. Thank you for following. Subscribe and share.